Welcome to another interesting session with Emmy. We'll take up examination style question and understand how do we solve such problems. You may join my classes, gain confidence, connect learnings, and get ready for future. Share the gift of education. Let us now enjoy the lesson with Emmy. Equation combination once again for you. So I'd like you to actually watch my videos on parametric equations and our previous lessons on that. That will help you to get through some of these questions, right? Can you please read?
Yeah. So figure 6 shows a sketch of the curve C with parametric equation x equals 4 cos t plus pi over 6 and y equals 2 sine t. Show that a Cartesian equation of C can be written in the form of x plus y whole squared plus a y squared equals b, where a and b are integers to be found.
Correct. So that is good. So we have to write Cartesian equation first, right? So how will you do Cartesian equation? You are given one in terms of cos of t plus pi by 6. And the other one is 2 sine t. So how will you eliminate sine t and cos t, where t is not just cos t, right? It is transformed. How will you do this? Tell me.
Can you put like a different variable, like u?
Okay.
Or would that confuse it more? Because to isolate t, obviously that's really hard with both of those. I don't know, can you square it and then, the sine squared plus cos squared equals 1 formula? I'm just saying things. I don't know which one's relevant. I'm just thinking.
Sine squared.
Yeah, I actually do remember when it comes. Yeah. Sorry, continue, sir.
So basically, you could expand this using a plus b formula. You get the idea?
Oh, cos a plus b.
Cos a plus b formula. You can use it. And then you will get that equation. Is that clear to you?
Yeah.
Right? So x part, x is equal to 4. Cos of a plus b is what?
Cos a cos b minus sine a sine b. So cos t cos pi over 6 minus sine t sine pi over 6. Oh, and then we can have sine t by y over 2.
Yeah, and then you make your special triangle, right? And pi by 6 you're looking at, which is this angle. And the sides are 1 to square root 3. You get the idea, right? And now you can substitute the value. X equals to 4. And within this, we are adding cos t. Cos pi by 6 square root 3 over 2.
3 over 2.
Minus sine t.
Sine t times a half.
Sine half. Times half.
Oh.
So you get this half outside, and you do have equals to 2 times square root 3
cos t
minus sine t. Is it okay?
Yeah.
So you get the value of x as something like this, and you need to find this particular equation. So from here, you can isolate. You can write sine t.
You can write sine t as y over 2.
Y over 2.
Oh, but then we need to get y as the subject.
Yeah, because y squared is okay. So we'll open the bracket, because cos t, and minus sine t is 2 times. 2 times sine t is actually, when you do 2 times sine t, and
it's y.
Is y only, right? So you can write anyway, right? Like this.
Yeah.
So basically it is y. Is it okay?
Yeah.
So you can bring y on this side. So x plus y is equals to 2 square root 3 sine cos t. Is it okay?
Yeah. Y.
Value, yeah, 2 cos t. So you can now find what cos t is. So x plus y over 2 square root 3 is cos t, correct?
Wait, why do we want cos t, sir?
Pardon?
Why do we want cos t?
Because we will do sine square t plus cos square t is 1.
Oh. So how do you know that we have to eliminate? Well, we have to eliminate sine and cos because it's not in the equation that they want.
Cartesian equation will never have it.
Oh
So
yeah, just x and y.
isolate sine t and cos t. So we got this, right? And we got this sine t as half of y, right? So this is y over 2 whole square, correct?
Yep. Plus
Cos
x
t
plus y
x plus y
over 2 root 3 whole
2
squared
root 3 whole square.
equals 1.
Correct. So now you can actually, it can be written in this form. So we have x plus y whole square and ay square. So we already have this form equals to
Can
b.
we just cross multiply?
Multiply. So the denominator is 4 times 3, right? You go for one more step, which is y square over 4 plus x plus y whole square over 4 times 3, right? Which is 12 equals to. Is that clear to you?
Yeah.
Now we are going to multiply by 12, right? So as soon as I multiply by 12, I get 3y square plus x plus y whole square equals
12.
Now we can compare, right? So we get x plus y whole square plus ay square. So a is equals to 3, right? And b equals to 12, correct?
Perfect. Yeah, I couldn't really see the first. I mean, I guess if I looked hard enough, I would have seen that the cos A plus B formula. But initially, when I looked at it, I was trying to make whole t plus pi over 6 like a different variable. But I definitely did think that would confuse me. But yeah, I think I just have to stop and think of everything I know about trig and then kind of try and apply it. Yeah.
Yes.
Well, that was all the questions there. But
good. But what you have learned today is a topic which you are not very clear of. And again, 5 more marks. You have gained a lot of marks here. I'll stop the video. I mean, sharing. Okay. Now I'd like you to summarize your learnings.
So I learned how to actually revise more effectively through kind of what we've shown today in terms of like gathering like questions, and within each question, when it comes to the stage close to your exam, the papers that you'll be doing would incorporate questions which are on multiple topics. When I read in the beginning all those topics, we saw like the first question when we did it, it had a lot of graph transformations, it had your derivatives, finding your stationary points, lots of like lines intersecting curves and things like that. So many things are like incorporated. And also in terms of all the questions I gathered, like without knowing, I just gathered the ones I didn't know. But we can see kind of like a common theme in terms of trig and like angle and kind of these formulas. So I now know that instead of just focusing on topics that I do know, try and focus more on these trig and other topics that I'm still struggling on. So that's how you kind of make a more kind of effective learning approach.
So, Amy, share with me all these questions which you discussed so that I can actually go through them once again and guide you further. Now, just talking to you, let me take 5 minutes and I'll actually revise your trigonometry and all the points which you need to remember. Is it okay?
Okay.
So that'll be a good revision. So what I saw is that you could not relate the trigonometric formulae, and every question involved them, which you shared with me today. So to begin with, let's do sine A plus B. So I would like you to review with me. Tell me, what is sine A plus B?
So sine A cos B plus cos A sine B.
And when I make it minus, it is minus, correct?
Yeah.
Cos A plus B.
So cos A cos B minus sine A sine B. It's like the sign invert. Yeah, plus.
What is sine 2A? Let's say
2 sine A cos 2 sine theta cos theta.
Easily, you can do this by substituting A equals to B equals to theta, correct?
Right, yeah.
What is cos 2 theta equals to?
So cos squared theta minus sine squared theta.
This could be written in 3 different forms, right?
Yeah. 2 cos squared theta minus 1. And 1 minus 2 sine squared theta.
Sorry.
And you get them from using the identity.
1 minus 2 sine squared. Correct. Let me write straight. You get this, right?
Yeah.
So these were some formulae which you should always remember, and so easy to get through, correct?
Right.
Now, from these formulas, you also get the angle cos 2 theta as equals to 2 cos square theta minus 1. If you rearrange, you can find half angle formula, right? So from here, you get 2 cos square theta equals 2. When you bring it there, it is 1 plus cos 2 theta.
Yeah.
And so you get cos theta equals to plus minus square root of 1 plus cos 2 theta over 2, right?
Yeah.
And similarly, you also get the formula for sine theta. Sine theta equals to plus minus square root of 1 minus cos theta over 2, correct?
Yeah.
I mean 2 theta, right? So they can be translated to half angle formula. And so we also have tan theta equals to sine over cosine, which is 1 minus cos 2 theta over 1 plus cos 2 theta. You get the idea. So
Yeah, the tan 2 theta one, I actually always forget.
yeah. So okay. So tan
What
A
was that
plus
one again?
tan A
Yeah,
plus
tan A plus B. Is it tan A tan B?
yeah.
Oh, tan
1
A plus tan B, 1 minus tan A tan B. Oh, I need to remember tan. I actually always forget that one. I don't know
and
why.
tan formula normally when it comes to you with angle A as 45 degrees. Very, very,
Oh,
many
nice
times.
number.
So tan 45 is 1. Do you understand?
1.
Tan
Yeah.
45 is 1. So many times you see the formula as 1 plus tan A over 1 minus tan A. So that means
Oh.
that angle is 45 degrees, which made that one number come. So tan A,
Oh,
you
I
understand? So
see.
many
Yeah,
times
yeah.
tan A is 1 if A equals to 45. You get the idea. So you have a formula many times in the question which is saying 1 plus, let me write tan theta here, over 1 minus tan theta. Is it okay? This also relates to tan of 45 plus theta.
Yeah. So this is the same as tan 45 plus tan
45
theta.
plus theta. Because that 45 is 1. So it's kind of tricky
Right.
sometimes. This helps, connection helps many times to see the solution. You get the idea.
Yeah,
You see the
yeah.
question and you see the solution. Oh, you're
Because
coming
with
from
one,
that
it's
place.
so hard. Yeah. Oh. Wow. I didn't see that. Yeah. And also, you know, the what for, oh yeah. Oh no, was it? I can't actually remember exactly, but there was a certain formula, and you can form it as difference of two squares. Or I think it was the trig identities.
I get you. So
Tan
this
squared
formula,
one.
right? Yeah, sine square theta plus cos square theta. Most of the time we are using this, right? We are saying sine
Yeah.
square theta equals to 1 minus cos square theta, and we are saying cos square theta is 1 minus sine square theta, right? Okay,
Yeah.
this is done most of the time. However, the other two formulae, which is 1 plus tan square theta equals to
Equals.
secant square theta. This is not used. Now 1 is equal to secant square theta minus tan square theta, correct?
Yeah.
Now this is difference of square. That means this is secant theta plus tan theta times secant theta minus tan theta, correct?
Yeah.
So from here, I can also write that secant theta plus tan theta is equal to 1 over secant theta minus tan theta. Do you see that?
Yeah, like that.
Or
So there's so
even
many ways.
theta minus tan theta equals to 1 over secant theta plus tan theta, correct? You get the
Yeah.
idea? Because we do not use this equation, so we are not very clear about it. And similar is the case when we have equivalent expression, which is 1 plus cot square theta equals to
cosec.
theta, right? So
Yeah,
that
because
also
I've had a couple
one
questions.
could be written as cosecant square theta minus cot square theta, and you can get similar results. You get the idea. So if you remember only this part of trigonometry, which we just discussed in 5 minutes, you can actually answer many questions very efficiently.
Yeah, no, because I had a couple questions that were kind of based on this, but because you have the standard form of the trig identities in your head, just to rearrange them, your brain's not kind of used to it. It kind of throws you off. But that question was all about just rearranging that formula. So it's so important to see it like this as well. So I'm going to try and look at it more, these kind of formulas. So it's like in my head. Yeah.
No problem. Okay, then.
Perfect.
All
Thank
the
you so
best.
much, sir.
My
I
pleasure.
really
My
appreciate
pleasure.
all your help, sir. Thank you so much.
My pleasure. My pleasure. Okay, then. Thank you. Bye.
Thank you, sir.
And
I'll
keep
see you
sharing.
tomorrow.
Keep
Yes, we'll
sharing.
do.
And then send your those files which you worked on to me so that I can look into deeper and
Okay.
suggest you something more what we
I'll
discussed.
attach it to the shared drive.
Okay.
Okay.
Great. Thank
Cool.
you. Bye. All the
Thank you,
best.
sir. Bye.